Assalamualaikum and good morning. My name is Nurusolihah binti Zamri, and today I would like to present about my project 1, which is about performance analysis of spectrum holes using wavelet-based sensing in cognitive radio. And my supervisor for project 1 is Dr. Mas Haslinda binti Muhammad. Let me go through the introduction in this project. Spectrum is known as the invisible radio frequencies that wireless signals travel through over. Nowadays, the spectrum resources are in high demand due to the rapid expansion in wireless application and service. To accommodate the rising number of wireless devices, a large number of spectrum is required. To overcome the pending spectrum crunch issue, the concept of cognitive radio has been introduced. So basically, there are two main users in cognitive radio, which are primary users as licensed users and secondary users act as unlicensed users. The basic concept in cognitive radio is to identify if the primary user is using the bandwidth that has been allocated to them. The secondary user will identify the available unused spectrum, which is known as a spectrum hole for their own use. A spectrum hole is a licensed bandwidth that has not been unused for some time, typically in a specific location. The secondary user strategically takes use of frequency gaps to optimize spectrum utilization. If secondary user detect a presence of primary user spectrum band, it will immediately stop using that band and switch to another one that is accessible to prevent interfering with the primary user. So in this project, the wavelet-based sensing is proposed in order to identify the spectrum hole. To overcome the issue of noise effect in the signal, the threshold method is proposed. By that, the best threshold will be chosen for increasing the performance of detection. By that, the performance of wavelet-based sensing approach can be evaluated. For the problem statement of this project, first, the challenge occurs in choosing the best method of spectrum sensing to detect and identify all of the spectrum holes in surrounding. For example, one of the mostly spectrum sensing approach that being used is energy detection. However, this method is ineffective due to it being difficult to choose a decision threshold. In addition, it also gives a low accuracy in detection of spectrum holes, especially at low signal noise to ratio. This will affect the performance of the spectrum sensing. The other issues that comes out in the cognitive radio is when the signal that has been transmitted can easily contaminated by the noise, which makes it difficult for the receiver to properly decode them. The objective for this project is first to formulate a wavelet detection algorithm using MATLAB software to detect spectrum holes in the measured frequency range. Second, to analyze the signal denoising to choose the best threshold for increasing the performance of detection. And the third is to evaluate the performance of the wavelet detection technique. For the scope of this project, first, the wavelet detection algorithm will be developed using MATLAB software at frequency 2.4 GHz. Next, the denoising signal will be analyzed by using the threshold approach. For this project, hard and soft threshold will be implementing in the process of signal denoising. After analyzing the signal denoising, the best threshold will be chosen for detection. And lastly, the performance of wavelet-based sensing is evaluated in terms of probability of detection and probability of false alarm. For project significance, this project can give benefits, especially to the 5G application. Along with being flexible and scalable, the network must also operate much more efficiently. The employment of cognitive radio in 5G can give a potential in improving the spectrum efficiency. This is due to the cognitive radio-based 5G can offer a very high data rates and quality of service application. Besides, cognitive radio also can be employed in the development of Internet of Things system. Nowadays, the demand for wireless spectrum has expanded quickly as the number of the users also increased by day. The interference will occur as device keep getting increased and has to move from one location to the next. By implementing this proposed project, IoT powered by cognitive radio can intelligently find interference-free channel for effective communications. So let me move to the literature review for this project. Before I start, I would like to go into introduction of the cognitive radio. First, cognitive radio is to address the issues of static spectrum allocation in order to provide dynamic spectrum access. The main goal of cognitive radio is to provide spectrum through flexible and opportunistic access to the primary user spectrum. Basically, cognitive radio components consist of primary users, which is as a licensed user, and the secondary users as the unlicensed users. In cognitive radio, the spectrum hole is known as the licensed frequency that has been vacant for some time, typically in a specific area. In the other words, the primary user did not use the particular band at that time. Therefore, in order to increase the spectrum utilization in the cognitive radio, the secondary user will strategically take advantage of spectrum voids. This figure shows the illustration of the spectrum holes. Spectrum sensing technique is one of the most significant elements in the cognitive radio. Spectrum sensing is used in order to detect the spectrum hole, and it also is used to optimize the probability of detection with low probability of false alarm. Spectrum sensing technique can be categorized into two types, which are narrowband and wideband sensing. This table shows the comparison between three types of spectrum sensing technique, which are energy-based detection, mesh filter detection, and wavelet-based detection. From this table, it can be concluded that the energy-based detection method is the most simplest method among others. However, this method does not give the good performance in the detection of spectrum hole. For the mesh filter detection, this method can give the good detection at all signals to noise ratio value. However, the complexity of this method is high. Therefore, the wavelet-based detection is proposed as it can give the effective performance at all signals to noise ratio value. Besides, this also do not require the prior information of primary user. So this table showed a few previous research that I have been referred in doing this project. We can see that most of this research use the wavelet-based detection as it can be used for wideband signal. From this paper, it can be seen that the wavelet-based detection can give good performance and better detection at high signal-to-noise ratio value. Besides, the complexity by using this method also not too high. Next, we move to the signal denoising. Noise is one of the challenges in the cognitive radio network. This is because the transmission of data between transmitter and receiver will be affected by this noise, which can affect on the quality of signal. The example of noise sources that can contaminate the signals are crosstalk, shadowing, and route loss. In order to solve the problem of denoising effect in the signal, the threshold method is being used as it is the simplest method to implement and requires the least amount of processing time. There are two thresholding methods that are proposed in this project. which are hard threshold approach and also soft threshold approach. This table shows the comparison between the hard threshold and also soft threshold method. For the hard threshold, the only wavelet coefficients below the threshold can be processed by hard threshold. Second, the hard threshold function can maintain boundary information more effectively. For the soft threshold method, it can reduce the absolute value of coefficient above the threshold. Besides, the denoising result using soft threshold is smoother compared to the hard threshold method. We move to the methodology of this project. For the first task, the wavelet detection algorithm will be formulated by using MATLAB software. In this part, the coding is constructed and involves a lot of calculations such as Fourier transform, continuous wavelet transform, threshold probability of detection, and also the probability of false alarm. After formulating the wavelet transform algorithm, the coding will be simulated multiple times to get the successful algorithm by using MATLAB software. If the algorithm is not effective, the algorithm is troubleshoot again until getting the successful algorithm. After acquiring the efficient algorithm, the signal denoising is analyzed based on the threshold method that will be used, which are hard and soft threshold. From these two thresholds, the best threshold is chosen for the detection of the spectrum hole. After the best threshold has been selected, the performance of the wavelet detection method will be evaluated in terms of probability of detection and also probability of false alarm. Next, this is the plot diagram for wavelet-based sensing. This plot diagram consists of 5 elements, which are wavelet transform, power spectral density, wavelet edge, threshold comparison, and sensing decision. So at the another part, I will explain more details about this plot diagram. The first element in the system model for wavelet-based sensing is wavelet transform. The input data signal will be analyzed by the wavelet transform function. The fundamental concept is to estimate the proportion of a wavelet that a signal contains at a given scale and location. A wavelet scales indicate how stretched or compressed it is. So this shows the equation of the continuous wavelet transform. Next, we go to the second element for the system model for wavelet-based sensing, which is power spectral density. The power spectral density is intended for utilization with continuous spectra. The integral of the power spectral density over a given frequency range is used to calculate the average power in the signal across that frequency range. So this shows the equation for the power spectral density. The third element of wavelet-based sensing is wavelet edge. In order to examine edge detection and estimation, multi-scale point-wise products of smooth gradient estimators are formed. This method aims to reduce noise while enhancing multi-scale speeds caused by edge. In order to extract the boundaries of the investigated spectrum, this function is again subjected to the maximum extraction process. We move to the threshold element. The threshold is the significance element in the cognitive radio as it can be used for the signal denoising. Signals are easily contaminated by noise during transmission, which prevents signal from being appropriately received by the receiver. Therefore, the polluted signals should be treated to eliminate noise and enhance the signal quality. In this project, The hard thresholding function and soft thresholding function are the two threshold functions that will be used in the signal denoising. Both of their concepts are the same, which is to eliminate small wavelet coefficients and reduce large wavelet coefficient. So, in this slide shows the mathematical equation for hard and soft threshold and also the equation for spectrum whole. The last element of wavelet-based sensing is ROC curve. ROC curve is a mathematical representation of the fundamental detection problem. The ROC curve is a graph of the probabilities of detection and probabilities of false alarm where they are parameterized by threshold. This shows the equation for probability of detection and also the probability of false alarm. This is the preliminary result of my project. This graph shows the measured signal of the data signal that has been imported into the MATLAB software. So that's all from me. Thank you.